And now I will give some examples of precipitation extreme events analyzed in previous workshop. And the first example is about some southwest China persistent heavy rainfall. And showing top left is anomalous precipitation, and that's a 21-day averaged from 21st June to 11th of July relative to climatology. And through here is a percentage change relative to climatology. And you can see, for example, over that period and over southwest China, the precipitation is about 120 to 150% relative to climatology. And associated with this heavy precipitation are anomalous southwesterly flow, which transport more moisture to the region and led to heavy precipitation during that period. And so here is the precipitated water. You can see, for example, in the region, and the precipitate water over that period relative climatology is higher. And so here is sea level pressure, and as you can see, for example, in the region, and there's low sea level pressure, and so lower sea level pressure is associated with cyclonic circulation in lower troposphere, and which transport, for example, moisture to the region led to the heavy precipitation. And so here is a time series, and one series is a fixed period, and that's fixed from 21st June to 11th July, and that's showing the bar chart. And you can see, for example, for fixed period, and 2018 is an extreme event, and so anomaly is about, for example, 70% of the climatology. And another way look this extreme precipitation is to look at the distribution of the 21-day maximum precipitation over the some period, that's from June to August, and that's showing red lines. And you can see, for example, in both, for example, fixed period precipitation, and that's about, for example, 70% of the climatology. And for the 21 max precipitation and 2018 is about 60% of the climatology. And showing the bottom left is 21-day max precipitation and fitted with the GeV fit. And you can see, for example, for maximum precipitation, that's 21-day maximum precipitation, and it's generally fit by the GeV fit. And this 2018. And you can see, for example, for 2018, some precipitation and the return period is about 30 years. And so use the MetaOffice, both historical simulation and natural simulation, and the group has analyzed, for example, first for the climatological distributions, and this for the climatological distribution that from 61 to 90, and showing the backline is observation and is PDF, and show red line is example average. And you can see roughly for the maximum 21-day precipitation, and the model captures, for example, observed distributions. And showing here is maximum 1-day precipitation distribution, and also, for example, multimodal ensemble simulation. For example, the PDF distribution is similar to, for example, model is similar to observed distribution, and indicate, for example, model can capture, for example, this the precipitation distribution realistically. And so this shows a PDF for 2018 simulations, and the red line for the real world, and blue line for the counterfactual world or natural world. And this dashed line is 2018 threshold. And you can see, for example, with include isoparentic forcing and PDF shift to to the left and indicate that, for example, for 21-day maximum precipitation and probability decrease by including or by including anthropogenic forcing, and in fact, and risk ratio of that kind of event in in the historic simulation related to the natural simulation, and it's decreased, and so the risk ratio reduced by about 40%. And so here is the PDF distribution for the 1-day maximum precipitation, and you can see, and in contrast to the 21-day maximum precipitation, and for 1-day maximum precipitation, and the PDF shift to the right, and it indicate, for example, human influence led to increase of probability of 1-day precipitation, and in fact, for the 2018 1-day maximum precipitation and probability increased by 1.5-fold. And why, for example, for longer duration precipitation and human influence led, for example, decrease of probability. And so here is a sum of mean precipitation changes between historic simulation and natural simulation. And you can see in terms of sum of mean, and you can see in a large area over East Asia, and the precipitation decreased due to the include of human forcing. And so here is a change of risk ratio with the duration of precipitation. And you can see, for example, for the longer duration, that's longer than 2 weeks, and the risk ratio decrease. But for example, for short duration of rainfall, and that's a 3-day maximum precipitation, and also daily maximum precipitation, and risk ratio increase. And so here is another precipitation examples, and this is from the last year workshop, and it's about extended season heavy precipitation during Southeast China happened in the from spring to summer. And you can see, for example, over that extended season, and the precipitation anomalies relative climatology, and it's above 120 to 150% of climatology. And so here is a time series of observed precipitation during that extended season, and black line is observation, and blue line is model simulation, and this is the shading is the uncertainty from model simulation, and you can see generally model capture, for example, interannual variability of this extended season precipitation, and in terms of 2019, and you can see it's the wettest, the third wettest on the record. And associated with this heavy precipitation, and you can see this loss of circulation anomalies, and so it's associated anomalies southwest with transport anomalies moist region led to heavy precipitation. And so here is a probability density function of model simulation and observations, and basically for historical simulation for the historical period, and you can see, for example, model generally captures the observed distribution. And here shows is for the 2019 simulations, and one include all forcing, one only equal to for the natural forcing, that's shown in blue, and for the all forcing experiment for 2019, and it's shown red. And you can see, for example, with include isoprenic forcing, the PDF shift to left indicate isoprenic forcing and led to a decrease of the heavy precipitation event. And this shows a retain period, and you can see, for example, the red line shows is historical simulation for 2019, and the blue line shows for the historical natural simulation for 2019. And you can see, for example, in natural simulation, and it's a 1 in 7-year event. But for example, with include all forcing, and it becomes, for example, 1 in 10-year event. And this is from hard center model simulations, and showing the bottom as from Sim5 simulations, and you can see, and for Sim5 simulations, and both the probability density function and the retain period change due to the isopacific forcing is very similar to hard center model result. And so from this result, and it indicates that risk ratio reduced, and it is about 0.4, and indicate isopacific forcing has reduced likelihood of heavy precipitation during South China by 60%. And so here is another extreme precipitation event, and that's also analyzed during last year workshop, and it's about spring Southwest China low precipitation event. And this highlight regions, and so in here it shows a time series of spring precipitation in observation and in model simulations, and once again, and you can see, for example, model simulation capture, for example, interannual variability observed precipitation quite well. And for 2019 spring, and this shows the sea level pressure and also the potential height at 500 hectopascal. And you can see relative to climatology, and during spring over the southwest China, and there's anomalous high pressure over that region, and this anomalous high pressure is associated with northwesterly, and which led to, for example, reduction of moisture transport from normal, for example, southwesterly, and led to, for example, reduced precipitation in the region. And once again, and this shows observed distribution of spring precipitation that in black line, and the red line is Hadley Center historic simulation from 1961 to 2010. And you can see, for example, in terms for the historic period, and the model simulation shows a similar distribution as observed precipitation, and indicate, for example, the model can simulate the observed precipitation probability. And so here is the probability change with relative to the natural simulation, and the red line shows the historical simulation for 2019, and the blue line shows the historical natural simulation. And you can see, for example, the with include all forcing and probability shift to the left, and that 2019 threshold, and you can see with include asymptotic forcing probability increase. And so from this, and the probability of 2019 Southwest lower precipitation event increased about sixfold. And the group also analyzed the sensitivity of the risk ratio to the domain size by changing, for example, by shrinking domain size by, for example, 1 degree in all four sides, or enlarge the domain by increase the four sides by 1 degree. And you can see, for example, the risk ratio is not very sensitive to the domain size. And it indicates, for example, with include isopacific forcing, and 2019 spring southwest drought probability increased, and this result is not very sensitive to the domain size. And this group also analyzed what caused, for example, this increase of drought event. And they looked at simple 6 simulations, and for 6 simple simulations, and we got, for example, historical natural simulation and historical simulation that include all forcing, and also we got a single forcing experiments that include greenhouse gas only, aerosol only, and natural only. And so here is the probability density function change from historical natural simulation to historical simulations, and you can see relative to the natural simulation, historic simulations shift to the left, and indicate, for example, asymptotic forcing led to increase of the low precipitation event in Southwest China. And here shows the individual forcing, and the blue line is natural forcing, the red line is due to the greenhouse gas. And you can see, for example, with included greenhouse gas only, the PDF shift to the right indicate, for example, the drought event decrease, the probability to drought event decrease. And however, for example, we include only aerosols and the probability density function shift to the left indicate aerosol forcing led to increase of drought event in Southwest China. And so in historical simulation relative to natural simulation, and increase of the drought event is due to the change of aerosol forcing. And so all above examples is about extreme event happening in China. And also there's one group, and that's in third workshop in Beijing that analyzed, for example, North Hemisphere simultaneous heat wave. And show here is a heat wave index. That's a special structure of heat wave over 2018. And you can see, for example, over 2018, and heat wave occurred, for example, over North America, West Europe, Central Europe, and also East Asia. And this is a time series of that simultaneous heat wave index. And you can see 2018 heat wave and its record-breaking event. And use hard recent historical simulation and also natural simulation. And this shows a PDF. And so blue line is natural world, and red line is historical world. And you can see, for example, for 2018 event, and in natural world, and there's no such kind of event happened. But for example, with the include of human influence, and the probability is increased, and it become, for example, 1 in 4 year event. And this shows the PDF from another model experiment. And you can see, for example, from another model experiment, and the PDF distribution is very similar from those from hard center models. And it shows, for example, in natural world, and such kind of event is hardly happening. But for example, in the historical world, that in real world, and this kind of event becomes, for example, 1 in 4 to 8 year event. And so that's all examples I want to show. And so I look forward to working with all of you with a new event in this year workshop. And I wish all you find the workshop is useful. And I'll stop here, and thank you very much for your attention.